Hi team. Today we're going to talk about var(x), or the variance of a discrete random variable. So we write var bracket x, this is like variance, sigma squared, right? And it is equal to ex squared minus expected value squared. Now, ex squared is the sum of px squared, and ex is the sum of px, and we're going to square that. So that gives us the second line here, sum of px squared minus sum of px all squared. Again, probably seems a little bit confusing at first, so what we're going to do is try two examples from the exercise, and I think that'll be enough to get you well on your way. Okay, number one, B. We are trying to find ex, or expected value, and var(x), or the variance of this discrete random variable, this probability distribution we have here. So in doing this, I'm going to add a line, px. Minus 2 times 0.1 is negative 0.2. Minus 1 times 0.2 is negative 0.2. 0 times 0.3, 0. And you can see that we'll just go along and fill these out like so. So the sum of all of these, if we add them all up, negative 0.4 plus 0.3 is negative 0.1 plus 0.2 is 0.1. So we know that the expected value is going to be 0.1. Now, to get var(x), we're going to also need to find px squared. Now, x squared is going to be 41014, and therefore px squared is going to be 0.4, 0.2, 0, 0.3, and 0.4. When we add all of those up, what do we get? It's going to be 0.8, 1, I think I'm getting 1.3 for this. It should be 1.3. And so var(x), or the variance in this case, is going to be this number here, which is what we've got here. So 1.3 minus the sum of px, and we're going to square that. So this is 1.3 take away 0.01, so we get 1.29. That's our first question. Hope that makes sense. Let's try another one. Over here we've got x is a random variable and ex is 3.7. And we've got to find a, b, and var(x). Now you can see there's two unknown values here. We know, first of all, that 0.1, 0.2, 0.1, a, and b all add up to 1. So if I add all my numbers here, 0.4, I get 0, oops, come back, 0.6 must be equal to a plus b, since it needs this, all of these values need to add up to 1. So I'm going to put a is equal to 0.6 minus b. I'll just call this my first equation here. Now, in order to figure out what a and b are, we're going to need some kind of simultaneous equation here. So the next thing I'm going to do is use my ex value. So I'm going to pop in a px here. So I get 0.1, 0.4, 0.3. Remember, we're timesing x by p, the probability, 4a and 5b. My next equation is therefore going to be 0.1 plus 0.4 plus 0.3 plus 4a plus 5b is equal to 3.7. Now, I can add all of these up, 0.4, 0.5, 0.8. So 0.8 plus, now I know what a is here, so I'm going to get rid of the a by inserting it in terms of b. And our next line, we're going to have 0.8 plus 2.4 minus 4b plus 5b is equal to 3.7. Well, what do we have here? This is 0.8 plus 2.4 is 3.2. I'll pull that across to the other side. So I'm going to get b is equal to, what did I say that was, 3.2? So it must be 0.5, in which case a is equal to 0.1. Now I can find var x. To find var x, I also need px squared. So let's go ahead and do that now. Well, I'll put my x squared values up here. 1, 4, 9, 16, 25. Px squared. This will be 0.1, 0.8, and let's see, 0.9, and what did we say a was? 16 times 0.1, oh yes, so 1.6, and 25 times b, what did we say b was? So this will be 12.5, I think. 12.5. So var x is going to be equal to the sum of px squared. So I'm going to add all of this line here. So what do I get? 12.5, 13.5, 14.3, 14.9. I think it's 15.9. Let me just do a quick check on the calculator. 0.1 plus 0.8 plus 0.9 plus 1.6 plus 12.5. 15.9 is correct. And then I'm going to subtract my expected value squared, which is 3.7 squared. Now what do I get when I do this? Well, let's check it out. 15.9 minus 3.7 squared is equal to 2.21. 2.21. And that's my final answer for that. Well, I hope this has given you enough information to start working with variance of discrete random variables. As always, email me, get in touch if you're struggling with any of this. I would love to be able to help. God bless. See you soon.